Okay, Math 1, I'm making this video just in case our quiz in class leaves us short on time in going through the new notes, okay? So I will put this video on YouTube and create a link in Classroom so that you can view it if needed, all right? Topic for today is really a couple things. So we're talking about coordinates, x and y values, distances, and midpoints. All right, and in the textbook, the relevant two sub-chapters you're going to look at is chapter 12a and chapter 12b. Okay, so when we say coordinates, really we're going to talk about coordinate geometry. All right, so the first thing that we want to be able to do is plot points that have x and y values on the coordinate plane. All right. So the way the coordinate plane works is we have two axes. This is a horizontal axis. The horizontal axis, right, that is going to represent for us our x values, or the first number in the ordered pair. Okay. The vertical axis, right, so the axis that goes up down is going to represent y values. Okay, and our convention will be that an ordered pair, these two numbers separated by a comma, the first number will represent x and the next number will represent y. So if we plot and label these points, the way we want to do this is to count out going right and left the x value. Okay, so positive numbers will go in the right direction. Y values represent, like I said, verticality, so positive numbers will represent moving upward, negative numbers will represent moving downward, and we need to clarify that this crossing of the axes, that's called the origin, so that is the coordinate value or coordinate pair 0, 0. Okay, so the origin equals the crossing of the x and the y axes, and it's the point or the ordered pair 0, 0. Okay, a lot of this is probably review, so let's go a little bit quicker through this. So the point 2, 4, well, that means I'm going to go right 2 and up 4. So 1, 2 up, 1, 2, 3, 4 over. That's my first value, and I'm going to label that A. Check. For point B, well, this means we move to the left and 7 up. So we're going to go 1, 2 to the left, 1, 2, 3, 4, 5, 6, 7, 7 up. And now I probably just lost that. So 1, 2, 3, 4, 5, 6, 7. Yeah, right there. Okay, so that's the point negative 2, 7. And that point is represented by the letter B. And point C is 5, negative 2. So 2, 3, 4, 5. Right there. That is point C. Okay, so first part done. Second part, if A and B are two vertices of a rectangle, right, find three possibilities for the other vertices. Wow. Okay. So rectangle means, that we have two pairs of parallel sides and 90-degree angles. All right. So I'm going to think of this in terms of slope. So to go from A to B, right? Oh, yikes, sorry about that. I do not know what happened there. Let's get rid of that keyboard. So to go from A to B, oh, I know why. I gotta be on the pen. So we're gonna draw a straight line there. Okay. Now, the slope to go from, and I'm going to actually do to go from B to A. We go, let's see, maybe it's really easier to look here. So in terms of y values, right, we go from 7 to 4, which means we go down 3. And in terms of x values, to go from B to A, we go from negative 2 to positive 2, which means we go right 4. All right? So basically, I'm thinking that we have a rectangle that looks like this, okay? Where these sides are parallel and these sides are parallel, all right? So there's gonna be more than one set of answers for this, all right? But all I'm gonna do is I'm gonna do the reverse. I'm gonna do the reverse of this, okay? So I'm gonna go, instead of, let's see, down and right, I'm gonna go left and down in an opposite way. So I'm gonna go instead of right 4, down 3, I'm gonna go left 3, 4 down. Okay, so I'm gonna go left 3, 4 down. And I'm going to do that both from B and A. Okay. So let me clean this up a little bit. Get rid of these guidelines and actually do. Whoops! Didn't want to do that. I got rid of the origin. So get rid of these guidelines and I'm going to count. So I'm going to go left 3, 4 down. Okay. So left 3, 4 down. So that means 1, 2, 3, 4. Oops, 3. 1, 2, 3. 1, 2, 3, 4. So that's the point I'm going to mark. All right. Get rid of these other guide points. From A, I'm going to do the same thing. I'm going to go left 3. 1, 2, 3. Down 4. 1, 2, 3, 4. All right. So now I'm going to connect those two sides, and I'm going to connect with green. All right. And then that last side, so I'm going to call this, well, we have point C. I'm going to call this point D and this point E. Okay. And then the last side, obviously, is going to go from D to E. All right. So 2 possible vertices here, right? 2 possible are, what would that be? D is 1, 2, 3, 4, 5, negative 5, 3. And E is negative 1, 0. To get a third, all I'm going to do is, instead of going left and down, I'm going to go left and up. Okay, so I'm just going to list one possibility for making a rectangle, and I'm going to go from point A. So I'm going to go left 3, 1, 2, 3, but I'm going to go up 4, 1, 2, 3, 4. So right there. Okay, right there. So that's 1 up and 1 over from B. And we'll do this in another color. Let's do this in like this nice yellow. All right. So if I did the same thing from A, I went 1 up, 1 over, right? Maybe you guys can see that this could be another rectangle. Okay. So I'm going to say that pair, right? That would be, let's see, 1 up and 1 over from B. That would be at yeah, I need to get a different color because that you can't really see, can you? Let's do orange. We'll just do blue. All right, so that would be 1 up and 1 over from B would be negative 1, 8, and 1 up, 1 over from A would be 3, 5. Okay, so this pair would create the green rectangle. Let's actually color code that. So this makes the green, and the 1, 8 and there's negative 1, 8 and 3, 5 pair, that would create the kind of cool looking, in my opinion, yellow. All right. So continuing with this, now what we really want to do is figure out how to find distance between 2 points. Okay, so again, I'm going to label these 3 points. I'm going to use a different color. I'm going to use like this this purple. Don't really use that often. So 5, 4 for A. 1, 2, 3, 4, 5. 1, 2, 3, 4. Right there. That's A. 8, negative 2 for B. So if that was 5, here's 6, 7, 8. Negative 2 is right there. That's B. And C is 2, negative 5. So there's 2. 1, 2, 3, 4, 5. There we go. That's C. Okay, the distance between A and B. All right, so this is probably our first big formula here. All right, that looks terrible, right? That looks absolutely awful. So let's get rid of that. And let's try this again. I think, can I just make a straight line? No, I don't think I can. Oh well. All right, something to work on. So, straight line roughly from A to B. I don't know, something like that. Okay. To find this distance, what I'm going to do is break this into a right triangle. So I'm going to figure out how far do I go down, right? I'm going to figure out how far do I go to the right. I'm going to make that a right angle, and we'll do that kind of automatically if we're going down, which is purely vertical movement, and right, which is purely horizontal movement. Okay? So if I want to figure out how far I go down, I'm going to say, and let's write this out first. So A is 5, 4, right? And B is the point 8, negative 2. So this distance, let's call this distance very creatively y, right? So y is going to equal actually the change in y values, which is 4 minus negative 2, which is 6. This distance here we'll very creatively call x. That's going to be the change in x value. So that is actually that is going to be 8. So I'm going to do the y value first because I want my distance to be positive. 8 minus 5. Okay, and 8 minus 5 is 3. So I've got this scenario where I've got a right triangle, right? That distance is 8. That distance is not 8. Come on, that distance is 6. This distance is 3. And maybe you guys heard of the Pythagorean theorem. So if you have a right triangle, right? This is B, this is A, this is C. We have this relationship that A squared plus B squared is equal to C squared. Well, here, that's my C. So I can say that C squared is equal to 6 squared plus 3 squared. So C squared is equal to 36 plus 9. C squared is equal to 45. So C is equal to the square root of 45. And by the way, on the calculator, that could also be 45 to the 0.5, or you could do 45 to the 1/2 power. But that, and I'm going to run this on the calculator now, that will be, let's see here. Whoops, I got to get a calculator that actually does roots. So let me open up PhotoMath, the PhotoMath calculator, which is absolutely fantastic. I think it's really good. So the square root of 45 is, as a decimal, rounded to 2 decimal places, 6.71. Okay? So that is our distance. Now, if we want to generalize this, which I think we will, right? The general formula for the distance between 2 points is the square root of, remember, we did Pythagorean theorem, right? And we got 6 and 3. How do we get those? Well, we got 6. We got 6 by subtracting the y values. We got 3 by subtracting the x values. So the total distance is equal to the change in x, which is x2 minus x1 squared. Okay, so that you know, this notation is a little bit confusing, but it basically just means take one of your x values, subtract the other. And if you square it, it's going to be positive, so it doesn't even matter if you get a negative value inside here. Okay? And to that, we're going to add the change in y values. All right? So this, massively important formula. This gives you the distance between any 2 points in coordinate geometry, assuming the distance between those 2 points is a straight line. Okay, and that's a big assumption that we're going to make. Okay, join A, B, and C to form a triangle. Find the length of BC and AC. So we're going to go back to this picture. And actually, you know what? I lied. I'm going to redraw the picture, not maybe to scale, but with the points. Okay, so got some room to do this. Let's make our axes in blue. Okay. So this is the x-axis, this is the y-axis, and A is in quadrant 1, B is in quadrant 4, and C is lower and to the left in quadrant 4. So I'm just going to roughly try and sketch this. So let's say A is there, B is somewhere here, and C is down here. And the important thing is for me to label these points correctly. So A is 5, 4. A is the point 5, 4. B is 8, negative 2. B is 8, negative 2. And I think C is 2, negative 5. But sometimes I don't trust my memory, so let me check that. Yeah. All right. So we're going to make a triangle out of these 3 points. Okay. And what we want to do is find the length of BC. So I really like this yellow color, guys. Sorry. So we want to find this length, right? And we also want to find the length AC. Let's make another color. Let's make this that green that I like too. Okay. So to find BC, we can abbreviate the length as capital B, capital C with a line segment over it. Okay, and I'm going to write, again, the distance formula that I have. The distance between any 2 points is the change in x, so subtract the 2x values and square them, plus the change in y squared, all square rooted. Okay, so BC, so this is going to equal, right, that distance is going to equal the square root of, now I need to subtract the 2x values. So for BC, so I've got 8 minus 2, 8 minus 2, 8 minus 2. Did I say that enough times? 8 minus 2 and square it. Now, I need to subtract the y values. We've got to be a little bit careful here because we got negatives. So negative 2 minus negative 5, all right? So negative 2 minus negative 5 squared. Okay, so what does that turn into? Well, that's going to be this first part. 8 minus 2 is 6. 6 squared is 36. Second part, negative 2 minus negative 5. This is negative 2 plus 5. Negative 2 plus 5 is 3. 3 squared is 9. So this is plus 9. So the actual length of BC is square root of 45. We're going to leave it like that to be exact. Okay. To find the length of AC, I'm going to use the green. It's a lot more visible than the yellow. Apologies for that yellow. Well, that's going to equal, now we need to look at, the difference between the x and y values from points A and point C. Okay? So change in x, I'm going to start with A, right? So I'm just going to do 5 minus 2. 5 minus 2 squared, so that's the change in x values squared. For y, I'm going to do 4 minus negative 5. Okay, and I'm going to, instead of 4 minus negative 5, I'm going to say 4 plus 5 squared. All right, what does that equal to? Well, 5 minus 2 is 3. 3 squared is 9. 4 plus 5 is 9. 9 squared is 81. So this AC length is going to equal the square root of 90. Okay, so that's AC. And where's my yellow? Root 45 is BC. Describe the type of triangle fully. I don't really know what to say by that. All right, so we haven't really classified triangles yet, so I'm just going to say, we're going to skip that part for now. Whoops. All right. Hey, there you go. So we've already talked about this, and we've used it as an example once, but very important formula. Okay, distance between 2 points. And you know what? Let's use this spare grid to actually illustrate it. Okay, so if I have some point here, whoops, I want to make that red. Let's make this a red. So I've got a point here. Well, very generally, the way that we could classify that point is x2, y2, right? And if I go over here and make another point, let's make it, right here in quadrant 3. Well, that point could be x1, y1, okay? And really, that formula gives us that distance, all right? Midpoints. Okay, midpoints. So some more plotting, but now instead of finding distance between, we want to find the midpoint. Okay, so D is 3, 0. I'm going to continue with the red, so that's point D. And E is 7, 0, so 4, 5, 6, 7. That's point E. All right, the midpoint of that, well, we know the Y value is going to be 0, I think, right? Because if we try and sort of guess on where the midpoint is going to be there. What's the X coordinate of the midpoint? Well, it's going to be the value that's halfway between 3 and 7. And to get that, we average them, right? It's 5. So the midpoint of DE is 5, 0. Okay, so this point, I'll label this, and I'm going to label it with a different color. Now I'm going to start going color crazy. Sorry, guys. So that's 5, 0. That's the middle. If we plot now point F and we say it's at 7, 6, well, E was 7, 0. So to get point F, I just need to go 6 up from there, and I'm going to use a different color. I'm going to stay with the red. So I'm going to go 6 up. So 1, 2, that's 3, 4, 5, that's 6. Okay, so that is the point F. Now this gets a little bit more complicated because we want to find the midpoint of this. What we do, right? And if we were to try and guess, we'd say, I don't know, maybe it's right there, right? But to find the midpoint, what we do is we take the average of both the x's and the y's separately. Okay, so if D is the 0.30 and F is the 0.76, well, if we take the averages of the x's and the y's independently, we're going to get the right midpoint. So let's do that, right? So for x, the average of the x's is, if I look again, and I'm comparing from D to F, so the average of the x's is going to be, well, I add the x's together, 3 plus 7, and I divide by 2, and that's 5. Okay? The average of the y values is going to be, the average, these two things added together divided by 2. So that's 0 plus 6 over 2, which is 3. So I'm a little bit off, right? My actual midpoint is right there. All right, and let's see if that's true. Well, I'm going up 1, 2, 3 over 2. If I go from D, 1, 2, 3 over 2, yes, this is the midpoint. Okay, so my visual estimate was off. It wasn't correct. Okay, and this point here is the point. Geez, what did we just say? 3. Nope. Sorry. 3 goes here. 5 goes here. Right? The x value is 5. That goes first. The y value is 3. Okay? So this point here is 5, 3. Make a prediction for the midpoint of EF. Well, we just kind of talked about it, right? We know now it's going to be the averages of the x's and the y's. So E and F, right? So E is the 0.70. F is the 0.76. So the average of 7 and 7 is 7. The average of 0 and 6 is 3. So 7, 3, boom, right there. Let's use a different color. Let's use, what have I not used? Let's use like this dark green. That's kind of cool looking. So that is 7, 3. 7, 3. Okay? Predict the midpoint between F and G, which is negative 1, 9. So negative 1, it's right there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yikes. If we want to go midpoint between F and G, well, we got to take averages of those two respective points. Okay, so this is point G now. So F is point 7, 6, and G is the point negative 1, 9. So the midpoint, I'm going to write this way. The midpoint is going to be 7 plus negative 1 over 2, right? So what this is doing is this is computing the averages of the x coordinates of each point, 7 and negative 1. And then the average of the y's would be 6 plus 9 over 2, okay? That negative 1's kind of looking like an absolute value, so let me make sure that looks like parentheses. And if we do the math there, 7 plus negative 1 is 6, 6 over 2 is 3, and 15 over 2 is like 7.5. So we're going to say it's 3, 7.5. So 1, 2, 3, there's 4, 5, 6, 7. Yep, right there. That is the coordinates. So the coordinates at that point are 3, 7.5. Okay, so this now we talked about. This you should be able to do. You should be able to do this now. Explain how to find the midpoint of a line segment. There it is. All right. So we'll illustrate it again. We'll make a point here, a point here. We'll call this point x1, y1. We'll call this point x2, y2. So I'm not going to be able to get this exactly without computing it, but I'm just going to guess and say, the midpoint is somewhere right around there. Okay, and the coordinates of that point are going to be x1 plus x2 over 2, y1 plus y2 over 2. All right, so this is called an arithmegon. All right, so the idea here is you fill in these blank spaces the midpoints between these 2 points. Okay, so in this left arithmegon, we have these 2 points. We want to find the midpoint. We have these 2 points. We want to find the midpoint. We have these 2 points. We want to find the midpoint. All right. This is a lot trickier because now you have the midpoints and you want to find the values that give that. It's a lot trickier. All right, but maybe examining this will allow us to do this. Okay, so to get this, and I'm going to write sort of outside to the left. So this box, the values of that, the x value is going to be 0 plus negative 1 over 2, and the y value is going to be 3 plus 1 over 2. So that means negative 1/2 and 2. All right. The midpoint of this guy and this guy, well, again, we're going to average the x's, we're going to average the y's. So that will be 0 plus negative 4 over 2. And then 3 plus negative 1 over 2. Okay? So again, to get this, I took 0 plus 4 divided by 2 to get the average, the midpoint. And I took 3 plus negative 1 divided by 2 to get the y value here. All right, so that will equal 0 plus negative 4 over 2. That's negative 4 over 2, which is negative 2. And the y value, 3 plus negative 1 is 2, divided by 2 is 1. Okay, this last one, I'm going to kind of compute in my head. Negative 1 minus 4 is negative 5, divided by 2 is negative 2.5. And 1 plus negative 1 is 0. 0 divided by 2 is 0. Okay, now, this other way of doing it. Right? The other way of doing it. To get, what do I mean by the other way of doing it? To get these, right? Well, can I figure out something with this value, 3, right? This has to be the x value here plus the x value here divided by 2. Okay, so I'm going to label this, and this is going to get a little bit complicated, right? That's okay. So I'm going to call this point x1, y1. I'm going to call this point down here x2, y, not 3, y2. And I'm going to call this point here x3, y3. Okay, so what do we know about this 3? Well, this 3 is the result of adding x1 and x2 together and dividing by 2. All right, so I could say 3 is equal to x1 plus x2 over 2. And really, that's the same thing as saying 6 is x1 plus x2. All right, great. So what? Well, now I can work this relationship with 5 and say that it's a result of averaging x2 and x3. Okay? So this is one equation that we like. The second one is that 5 times 2, so I'm going to kind of, instead of dividing x2 and x3 by 2, I'm going to move the 2 right away over. So I'm saying 5 times 2 is equal to this plus this. And I know it's a little bit quick, but that's so that we can get, we can save some room, to be honest. All right, so I've got that. And the last one, 7, well, that's going to be a result of x1 plus x3 divided by 2. Okay, so the last equation is that 7 times 2, whoops, I forgot to times 2. Okay, so guys, this is trying to go a little bit too fast. So 7 times 2 is 14, and that's got to equal the sum of x1 plus x3. So we've got a system of 3 equations, 3 unknowns, right? It's getting a little bit tough here, but we have 3 equations and we have 3 unknowns. Our unknowns are x1, x2, and x3. All right. So what we could do then, right? What I would do is I would probably substitute this equation, and I'd solve it, and get an expression in terms of x1. I take this equation, get an expression in terms of x1, and then I would solve the whole thing. Okay, so I'm going to do that and leave the y2 to you. I won't include it in the video, but I'll put it in the filled-in notes at the end. All right. So I'm actually going to do that after this because I want to get to this last question. All right. And just point out that, this, we say color groups. That was last year. We unfortunately can't do that right now. So I'm going to say work with your breakout room groups. And then again, we can't work on the boards. Aww. So what are you tasked to do in your breakout rooms? Well, you've got these 3 givens, this point A, this point B, this point C, right? You know that D is the midpoint of BC, so you can compute that. And you want to prove that triangle ABD is right angled. Now to do that, right, that means that you want negative reciprocal slopes, not sloped, slopes at the 90-degree angle. So for example, if the slope of one line one line is A. The slope of the second line, if it's negative 1 over A, it means that lines 1 and 2 form a 90-degree angle. Okay? So I'm going to stop the video in a second. Right? You got your homework here also. And when you look at the filled in notes on Classroom, you'll see the answers to this, 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 and the answer I got to this. Okay? So that was a lot of stuff. We will pick up some of this next class, the class after the quiz, but